Okay. All right, Maureen, did you get a chance to look at any of your homework?
I didn't even find it. I didn't even get to find it. But then I find it yesterday, and then I could get that and do. Yeah. But
Oh,
I
you did.
tried. I do number 4, but that was
Okay.
what I do just now when I was here sitting down.
All right. Let's just let
But
me
I didn't get
share
to
my.
do 3.
Oh, okay.
So
That's all right.
I traded, right?
Okay, that's all right. We'll do them together. Let's see. All right. You did number 3?
No.
Okay. All right. Let's look at number 3. A trader gains 1/3 of the cost price as profit on a product and 1/4 of the cost price as profit on another product. The total profit earned on these 2 products is $43. The sum of the cost prices of 2 products is $150. Now, your task was to write 2 simultaneous equations to show this, right? Now, okay, so here's what we need. We need the 1/3 and the 1/4. 1/3 on one product, 1/4 on the other. We need the total profit on those 2 products, $43, right?
Yeah.
And we need the sum of the cost of the 2 products, $150. So that's what we need from this word problem. Now, let's just say we'll take some variables here. We'll use X and Y. So we'll say let
X.
Okay. Back up this and see if I can get it on the largest. Okay. Let X equal. What do we want to let that equal to, Maureen?
Okay, let's see.
Well, cost price. Let X equal cost price of, well, we'll say product 1. So we have 2 products, right? I'll make that bigger so you can see it. Let X equal the cost product of product 1. Okay, make that bigger. Okay, then we're going to say let Y, just copy that. Now product 2. Let Y equal the cost product of product 2. You could use any variable. You could have said A and B, but we'll just use X and Y. Okay, so now what do we know about the cost product of product 1 and product 2? What are some things they gave us we know about?
This is 1/3 profit of 1%.
This right here, the sum
The
of the
sum
cost prices of the
is
2 products
is
$150.
$150.
So what can I write equation to show that, Maureen? If X is the cost price of product 1, Y is the cost price of product 2, what can I write? What equation can I show that the sum of those 2 cost prices is $150? What would that equation be?
Or then you got to write the sum.
Yeah, how would I write that as an equation? In other words, translate the sum of the cost prices of 2 products is $150. Translate that to a mathematical equation. What would it be? Well, X is the cost price of product 1 and Y the cost price of product 2. What would I write?
You write like 150.
What is 150?
That is total.
Okay, so tell me how to write the total using my X and Y.
X plus Y right?
Right, very good. X,
Equals to 150.
that's it, that's it. X plus Y equal 150. Yeah, let's just make this the small x, okay? Yeah, the sum of the cost price of two products is 150. So that's
Yeah.
what that translates to. X plus Y is 150. Now, how do I show that 1/3 of one of the cost price is the profit and 1/4 of the other cost price is the profit, and the sum of those two products is $43? How would I show that?
Okay. So what we would do, let's see, they want to know, let's see,
When you say 1/3 of something, what mathematical operation is that?
1/3.
Well, that's the fraction, but what operation? Am I dividing, multiplying, subtracting, dividing?
I think it's, let me see, they want the profit. So
When you,
it got
when
to
you
be
say 1/3 of the cost price, how do you write that, Maureen? How do you write 1/3 of the cost price? Say it could be X. And how do you write 1/4 of the cost price? It could be Y. How would I write that?
so I put X plus Y equals, let's see if it's going right. Okay.
See, 1/3 of the cost price is profit, right? That's product one, say, and 1/4 of, say, the product two, 1/4 of the cost price is profit, and the total profit of those two products is $43. How do I write 1/3 of the cost price of product one? How do I write that mathematically?
Let's see, mathematically. I can't remember, Miss Barbara.
1/3 is a multiplication. So I would
So
say
you put 1/3
1/3 X.
times?
Yeah, 1/3 times X.
Uh,
Okay. And that would be added to what?
1/4
1/4 what?
plus X.
No. What's
Y.
the other? Y. 1/4 Y. And what's that equal to?
1/3 plus 1/4,
What's the total profit?
$43.
So that would be 43. Those are your two equations. Those are your two simultaneous equations. Cost price of product one plus the cost price of product two is $150. That's the sum of the cost prices of the two products is 150. That's this equation. The second equation says 1/3 of the cost price is profit. So we said 1/3 times X plus the second product is 1/4. 1/4 times the cost product. And that's equal product. The total profit earned on these two products is $43. So when we take 1/3 of the cost price of product one, we get the profit for product one, right? And we take 1/4 of the cost price of product two, we get the profit for the product two. And when we add those two together, we get our total profit.
190.
All right, is that clear, Maureen?
Yeah.
Okay, so those are your two.
193.
Hmm?
So then it gets 193.
Where are you getting 193?
You add 43 and 150.
No, that's not how you solve. How would you solve these equations? No, you wouldn't add these. If you try to do elimination, you try to do what? Get it down to one unknown. So if you were going to do elimination, you would say X equal 150 minus Y, and then substitute that value in for X. You can't just add these because you have, by elimination, you get it down to, instead of 2 unknowns, get it to 1 unknown. So this then would become X equal 150 minus Y, right? Because if I subtract Y from both sides on the left side, I just get X left.
Okay.
And then you could take this equation and substitute it here for X. And then you'll have just Y left. Okay, so this I'll just put here, substitute for X in number 2. Okay, I'll call this is equation 1.
Mhm.
This is equation 2. So you take this 150 minus Y, substitute it for X here. So what does that become? That becomes 1/3. And we said we substitute for X, 150 minus Y, right? 150
Mhm.
minus Y. And that will be plus 1/4 Y equal 43. Now you just have the Y unknown, right? Then you could solve for Y, and then from that you could solve for X. You could just add those two because you still would have X and Y. Remember, you're trying to get it to 1 unknown, and once you solve for that one, you can use that one to solve for the other one. Because once you solve Y, you can subtract the Y from the 150 and you'll have X. Okay, but this equation, this problem, you just had to write the 2 simultaneous equations, and that's what we did. But if we wanted to solve it, this is the way we would get started. We would take this equation 1, subtract Y from both sides, that becomes 150 minus Y, substitute that X value here. That's why we have 1/3 X, 150 minus Y. Now you'd have just Y left. So you can do the arithmetic and solve for Y, and then use number 1 to solve for X. Got it?
Probably didn't understand what the word similar. What's similar what?
Simultaneous.
Yeah, probably didn't
Well,
understand.
simultaneous equations are equations that share the same variables.
Oh.
All right. See, X and Y in number 1, X and Y in number 2. See, they both have the same variables. That's what simultaneous equation. So we've been working with them with 2 variables. And with 2 variables, we have to solve them by elimination, substitution, or if we had a graph, we could graph them, and where the 2 lines intersect would be the value for X and Y.
Okay.
All right. Simultaneous equations are equations that share the same variables. That's all they are. And number 1 and number 2 or simultaneous equations, the variables they share are X and Y. See, X and Y in number 1 and X and Y in number 2. All right, Maureen, did that clear that up for you for simultaneous equations?
Yeah.
Okay, you said you did number 4, right?
Yeah.
You did number 4?
You want me to dollar bills, right?
Okay. So this one you was also to write simultaneous equations. So what did you write? Well, 20. You're given, she has a total of 23 bills. Yeah. Of 20s and 5s, right? And the amount of money she has is $340. $340. So those are the 2 things you need to do your simultaneous equations. So Maureen, what variables did you use? What did you use for your variables?
That's how I do mine.
Okay.
I do mine as 13 20s, right?
As what?
This here was 23 bills, right?
23 bills, right?
Yeah.
So what did you do?
Okay.
What were your variables? You got two variables here. What are your variables?
X and Y.
Okay, so X represent what? The 20s or the 5s?
The 20s.
Okay, let X equal $20 bills. Okay, and then you said what? What was your $5 bills? What variable?
Y.
Okay,
Y.
let Y equal $5 bills. Okay, now what's your first equation?
I do 13. 20,
Right.
13 of each 23. I do 13 into 20.
No. How did you write 23 bills of 20 and 5? How did you write that equation? This is
I
number of $20 bills. So let's just put
just
right.
I do shortcuts.
Number of $5 bills. Okay.
Anyway, all of that.
Now, how did you show that the sum of the 20s and the 5s is equal to 23?
Okay, this is this is what I do. I put the number of $20 was 13.
But that's not what they ask you, Maureen. They say write the two simultaneous equations that can be used to find the number of bills. So how did you write that first simultaneous equation? What adds up to 23?
As a 23.
Mm-hmm.
11 and 12.
No, I don't want numbers. I want variables. What variables add up to 23 bills?
X
That's right.
and Y.
That's right. X plus Y equal 23. Because the number of $20 bills plus the number of $5 bills is 23. So that's your first equation. All right, that's your first simultaneous. What's the second one? That's number one. What's your second equation? Now, if the amount is 340, what adds up to 340?
The amount 3 for X plus what is it 23.
The amount 340 is the amount for the $20 bills and the amount for the $5 bills. How do you write that in the equation?
Okay, let me see. Put 20, right?
Okay, 20 what?
$20 plus $5.
No, 20
Or
times.
20X.
That's right, 20X. Very good, Maureen. Plus what?
5Y.
That's it, 5Y. And what's that equal to?
340.
340. That's it. That's it. That's your two equations. Now, see, you want to go ahead and solve it, but that's not what they ask you. What
I
did
tell
they
you that
ask you?
I thought when I was telling that word similar, it was confusing me.
Simultaneous.
Yeah.
Yeah.
Oh,
Simultaneous
you don't know.
equations share the
Oh,
same variables.
oh, I see now.
So when they ask you to write the two simultaneous equations, they didn't ask you how many $20 bills and how
Oh,
many $5 bills did Emma have in her purse. That's
well,
another step.
no, realize what that word means. It was me confused again.
Right, right. That's simultaneous equations that share the same variables. So you write first, the sum of the two bills is 23. That's
Oh,
because she says Emma had 23 bills. And those bills are made up of $20 bills and $5 bills. So once you say X, the number of $20 bills, Y, the number of $5 bills, and X plus Y is the total number of bills, 23. Now, a $20 bill is worth 20. So 20 times the number of $20 bills would give you the amount that was 20s. 5 times the Y gives you the amount that were $5 bills, and they add up to 340. That would be the answer to that one, Maureen. The two
okay,
simultaneous equations. Got it?
okay.
All right. Now, if they ask you to find how many, then that's what you're saying. You went and found. So how many $20 bills did you say there were?
I say, uh, 13, I think I said, or something like that.
You said 13.
Uh-huh.
Okay. And how many fives?
But I had so much, I had to do wrong anyhow. Like, five was too much money. So I
Uh,
realized it was, the five was, it wasn't right because I realized the five was so much money I had there. Yeah,
okay. You said 13 20s.
yeah,
That's 260. And then you have
yeah.
$80 left over. And 5 in the 80 goes how many times?
400.
How
5 X
many?
is 40.
Hmm?
5 X is 40.
No, 5 in the 80. Because if you said
Oh,
13, that was 260. And then you had 260 from 340 is 80. Then what I ask you is how many fives does it take to make up $80?
oh,
So that's 80 divided by 5 gives you 16.
16, yeah.
Yeah, that's how you could find, because if you took your 20s and you said 13 and you got 260, you have to subtract the 260 from the 340.
Huh.
That's $80 left. The $80 left would be in $5 bills. Okay. All right. But this is any questions on simultaneous equations, Maureen?
Not now. Do I realize what
Now
the
it's clearer
meaning?
to you, right?
Yeah, I should think
Yeah.
so.
It's translating your words to the math,
Okay.
right?
Uh-huh.
And normally they would give you say if this were multiple choice, they give you choices of these equations and you pick the right one, and the one that matches these would be the right one. Okay. All right. What about, did you do number 5?
No. I
Okay.
put, okay.
Okay. Okay.
Then
Did
I'm
you
up with it.
start number 5? Number 5 is a little more involved.
Yeah. It's a senior class. And then it tell you here, okay, class, the high school A rank and failed one van and 6 buses with 372 students. Right?
Right.
So I could say, okay,
So you have two high schools. Okay.
yeah.
A rented 1 van and 6 buses with 372 students. Okay.
I say let A be high school, right?
Okay. All right. Let's put what you put. Okay. You said, so your variables, you said let, what is A equal to?
A equals this 372 students.
No. Remember, you talking variables here.
Let A, it went one van and 6 buses.
Yeah,
The
high
tra-
school A rented fill one van and 6 buses.
yeah.
Now, you're trying to find these simultaneous equations we use to find how many students a van can carry and how many students a bus can carry. So you used A to represent what?
It has to represent the vans.
No, the students in the van,
Oh,
right? Let
yeah.
A students in the van. And what is B? What was your other variable? Was it B?
Yeah.
And what was B?
B was students in the bus.
That's right. Students in the buses. So students in the vans and students in the buses. Okay. So high school A. Let's go to high school A.
Mhm.
So how would we write the equation for high school A?
High school A. High school A had like one van and 6 buses, right?
Right. So how would I show that as an equation? And that was 372
Two
students.
students, yeah.
So
So
how would I write that?
okay, high school A equals to 372, right? Plus B equals to
So what adds up to 372?
the student, the van and the bus is,
The students in the van and the students
yeah,
in the buses add up.
yeah.
Right. So how would I show that, Maureen?
Okay. High school A.
Let's start with the van. How many vans did high school A have?
High school A had one van.
So that would be one van times the number of students in the van, which would be A, right? Plus, and how many buses?
6.
6. So it would be 6 times the number of students in the buses, which would be B, right? And what does that add up to?
372.
That's right. That's equal to 372. Okay. Now let's go to high school B.
High school B.
High
4
school B
vans.
had what? So what would I
4
write?
vans.
So what
High
would I
school
write for
B
B?
equals 4 vans.
Okay, so what would I write?
Okay.
The number of vans times the number of students in the van gives the number of students. So how would I show that, Maureen? How would I show how many students?
4 vans.
So how would I write that?
4 vans is V van.
No, we're using A for vans and B for buses. A for the students in the vans, B for the students in the buses. So
it'd be 4A.
That's it, 4A. How many buses?
Plus 12.
12 what?
B.
That's right. What is that equal to?
16.
No. How many students make up?
780.
780, right? Those are your two simultaneous equations.
Huh.
Okay. See, you let the variables be the students in the van because they gave you the van number and the bus number, right? And they gave you the total of the students. But to find the students in the van, you'd have to multiply the number of vans times the
Oh,
number of
you see.
students, right?
Oh,
Because this number is students, right? So van, so if you had two vans, say
oh,
if this was a 30 and then one van, that would be 30 students, one time 30.
uh-huh.
So
Okay.
it's the number of vans times the number of students in the van, number of
Uh-huh.
buses times the number of students in the bus, in one
Okay.
bus, and that adds up to a total number of students. So those are your simultaneous equations. All right.
Uh-huh.
Now, Maureen, how would you solve this? How would you think the best way to find how many students are in each van? How many students a van can carry and how many students a bus can carry? What would you say
I just, what I was gonna do, I was gonna add up the 780 and the 372.
Why are you going to add it up?
And I was saying there was like 4 vans and one is 5 vans, right? And I was saying 12 and 6 is 18, like 23, right? And I was going to add them to and then divide it by the 23.
Why would you add them? You gotta either use elimination or substitution to get it to one variable, so you can solve it. Then you can solve for the other variable. So if you had, let me just copy this equation. Put it here, okay, and copy the other equation. Now, let's use elimination to solve this. So how could we solve this with elimination? How could we solve this equation with elimination? How could I eliminate one of the variables?
You could see.
How could I make, let's see. Well, there's one way you could do it. See, this is a 6B and this is a 12B, right?
Yeah.
If I could make this a 12B, then I could subtract equations, right?
Uh-huh.
So how could I make this 6B a 12B?
Six B, by adding 6B to it,
No.
by multiplying by 2.
Yeah, yes, multiplying by 2. You could multiply. Now you'd have to do it to the whole equation. Multiply the whole equation by 2. Okay. Now, Maureen, what does that give you?
Well, you got my friend said 2 6 would be 12.
Okay.
And
so what would this be equal to when I multiply the whole equation by 2? What's 2 times 1A?
2.
2 what?
A.
That's it. Very good. 2A, right? What's 2 times 6B?
5B.
That's it. Very good. Okay. What's 2 times 372?
3 times 2, 72.
Yeah. 3 times 372. 2 times 372.
That's 3 2 is 6, 3 7 is 21. 3 3 is 9.
2 times 2 is 4.
4. Or you say 4.
2
You say
times
3.
2 times 372 is
Oh,
equal to what?
2 2s is 4.
Right?
2 7s is 14.
Mhm.
2 3 is 6 and 1 is 7.
So what's the number?
744.
Right, 744. Now, see, we have a 12B, right?
Mhm.
All right, so we have 12B. We can take this equation, okay, and subtract it from this one. All right, let's do this. Okay, so we'll subtract, and then you'll see we'll have just one variable left. Then subtract. Okay, so let's draw a line and subtract. What's 2A from 4A?
2A
That's right, that's 2A. And 12B minus 12B,
is just 0.
just 0, okay? So
B
that's
2A
plus
B
0.
0.
And 780 minus 744.
That is 4 from 10 least 6.
Okay,
1 and 4 is 5 from 8 least 3.
so 36.
35. 30.
No, 4
Yeah,
from 10,
36.
you said 6,
Yeah,
36.
yeah, yeah.
So 2A is 36. So 2A. So we know what A is. What is A equal to?
38.
No, Maureen. 2A, 2 times some number is 36. What is that number?
18.
That's right.
No.
That's right, 18. Then A is 36 divided by 2, which is equal to
18.
18. So students in the van is 18. Now, how could we find the number of students in the bus?
Okay. F
We
18
know A. How can we find B?
by multiplying 780. They
No,
find B.
well, we can take either one of our equations. We can take this equation or this equation and put what A is equal to and then solve for B. So which one of the equations you want to use? A, high school A or high school B? Doesn't matter.
High school B.
Okay, so we want to use this one.
Yeah.
You really should have used this one.
Okay, high school.
Because it's easier
High-
because 1A
high
is
school.
just 1 times 18, right? Always pick the one that's going to give you less calculation.
Okay.
Okay, it doesn't matter, but I'm just saying, let's make your work easier. So we'll take this equation and substitute. I want you to do that and tell me what you get for B. Substitute 18 for A. So do that, Maureen, and tell me what you get.
So that means you subtract 18 from both sides, right?
No, you're going to substitute. Let me just go here.
This is substitute
Okay.
18.
Yeah, that means where you see A, you're going to put 18.
Uh-huh.
So that means this is going to be what?
18A.
No. A is 18. So then I'll put 1 times 18
is 18.
plus 6B
Uh-huh.
equal
Plus the 372.
372. Okay. Now this 1 times 18 is just 18. So 18 plus 6B equals 372. So what do I do next, Maureen? Remember, I'm trying to solve for B. So what's my next step?
Subtract.
Subtract what? You're right. What will I subtract?
18 from
That's it. 18 from both sides. Very good, Maureen. Okay. Subtract 18 from both sides. Okay. So let's do that. Go ahead and subtract it, Maureen.
Okay.
Because on the left side, you know you'll get 0, right?
Uh-huh.
18 minus 18 is 0. So you'll just have 6b left. So minus 18. And subtract the 18 from the 372.
Okay. 8 from 12 is 4.
So on the left side, I'll just get 6b because 18 minus 18 is 0. What's 18 from 372?
8 from 12 is 4. 2 from 7 is 5. 354.
Okay, 3, 5, 4. Now, what's my next step, Maureen? What's the next step?
Okay, 354. Then you divide
That's it.
by both sides.
Okay, so divide both sides by what?
6.
That's it. Very good. Divide both sides by 6. So this becomes B equal 354 divided by 6. And what's that equal to, Maureen?
Okay, 354.
354 divided by 6. What do you get?
59.
That's it, 59. So what does that mean? So that's equal to 59. That's how many students
Within the bus.
in the bus. So that's how many buses you need, because that's students
59.
divided by 6. So you need then what? How many vans? 18 vans and 59 buses. That would be the answer. Okay. And then you could carry all of the students that we mentioned for the schools.
Okay.
All right. Did you look at number 6, the next one? Okay,
Go ahead.
let's go to number 6. Okay. And what we're doing again is translating the words to the math.
Okay.
Now read number 6, Maureen.
MS Kit were at a music store. Last week, she sold 6 more than 3 times the number of CDs that she sold this week. MS Kit sold a total of 110 CDs over the 2 weeks. Orbit system of equation can be used to find
L
and the number of CDs she sold last week, and T, the number of CDs she sold this week.
Okay,
So you got to put
last week she sold 6 more than she sold this week. So you know you're gonna need that, right? And over the 2 weeks, she sold 110. Right? So that's what you're gonna need. They gave you the variables here, right? They said L equal number of CDs sold last week, right? Number of CDs sold last week. Okay. What's the variable for the number of CDs sold this week?
6 more than.
No, T. We're doing just the variables now.
Or
T equal number of CDs.
Sold this week.
That's right, sold this week. All right. Now, we know that she sold 110 over the 2 weeks. So we know the one sold last week plus the one she sold this week is 110. How do we write that, Maureen?
Okay.
How do I write the total sold over the 2 weeks, last week and this week, using the variables?
T, L and T, L plus T, right?
Right, very good. L, because the total you're gonna add, right? L plus T, and what is that equal to?
6 times more than 3 times.
No. How many, she sold how many CDs in 2 weeks?
110.
110, so
110.
that's 110, right? Number of CDs sold last week plus the number she sold this week, that's over the 2 weeks, so that's 110. Now, how do I write last week she sold 6 more than 3 times the CDs she sold this week using my variables L and T? How would I write that?
Okay. L plus T equals 110. So the next thing we will do is okay.
So last week, which is L,
So it will be L
okay,
equals
okay. 6 more than means what operation?
add,
Right. 3 times means what operation?
multiply.
Okay, so tell me what to write.
Okay, L equals I don't know.
How do
6
you,
more.
how do you write
What?
3 times the number she sold this week? Where T is the
3
number.
times 110.
No, that's the number she sold over the 2 weeks.
Uh,
What represents the number she sold this week?
T.
T. So that would be 3T, right?
Oh,
3 times the number of CDs that she sold this week. That would be 3 times the variable T that represents the number of CDs she sold this week. Now she sold 6 more than that. So how would I write that, Maureen?
6
What operation?
times
No. You said 6 more than was add.
uh,
So what would I?
plus
Okay, plus.
6.
That's it. Plus 6. 6 more than 3 times the number she sold this week. So 3T represents the 3 times the number of CDs she sold this week. And 6 more than means to add the 6. Those would be your 2 equations. Which system of equations? Those would be the 2. L plus T, the total sold over the 2 weeks, 110. The sold last week, 6 more than, add 6, the 3 times the total she sold this week. And that's it. Questions, Maureen?
That's it.
That's it.
Cool.
It just say which system of equations. We didn't have to find how many CDs she sold. We just needed to set up the equations. So you're translating the words to the math. Got it? Okay, now the next thing we want to do, we have some simultaneous equations, and I want you to solve them. Equations that share the same variables. Okay, Maureen, now this one, how would you solve this one?
Okay. Okay, let me see.
Now you see something they have in common. That means you can do what with these equations?
You could multiply 3y by 3y.
Why would you multiply? When you have a 3y in the equation 1 and you have a 3y in equation 2, so you can subtract them.
Uh,
Okay, subtract the equations.
2 from 5 plus 3.
That's right. You can just subtract the equations. So let me just copy them here. All right. Because you've already got something in common there, the 3y. So you can subtract them, right? Okay, so let's draw a line here and subtract them. And 2x from 3x is what, Maureen?
1x.
2 from 5?
Oh, you said 3. 2x, 3x.
3x. So that's 3x. And 3y minus 3y.
0.
All right. So that's 0 plus 0. And 41 minus 20.
21.
21. Okay. So what we have is 3x plus 0, which is just 3x equal 21. Now, only one number multiplied by 3 to get 21. What's that number, Maureen?
7.
7. So that's our answer. X equal 21 over 3. And that's equal 7. Now, so we have X, Maureen. How would I solve for Y?
Okay.
Now you can take either one of the equations here. Plug in the X and solve for Y. So do that. Either equation, the 5x plus 3y 41 or the 2x plus 3y is 20. Put in the X value of 7 and then solve for the Y. Tell me which equation you'll use.
Okay.
Let's see this. Which equation are you going to use, Maureen? Doesn't matter. You can use equation 1 or equation 2.
I can use 1.
You're going to use 5x plus 3y is 41. This one?
Yeah.
Okay, so let's take this equation. Copy it. Substitute for x7. Substitute 7 for x. All right. So where you see an x, you want to put a 7, right? So let's just take this and put our 7 here. So x, we're going to put a 7. So that would be times 7. Now you see we can solve for y. What's 5 times 7?
35.
35. And that's
Plus
plus
3.
3y
Okay.
equal 41. What do we do next, Maureen?
Let's see, we divide.
No. You need to get your constants together, 35 and 41. So what would you do?
35 add.
Yeah, but you're going to still have 35 plus 35, 70. You're trying to get 35 on the side with the 41.
Oh.
So you do the opposite of adding. You'd have to subtract 35 from
both sides.
sides, right? So subtract 35 from both sides. Okay. So this is minus 35.
Mm-hmm.
And on the right, minus 35. Okay. So on the left, 35 minus 35 is 0. So you'd have
Yeah.
3y equals, what's 41 minus 35, Maureen?
6.
6. Now you know your answer. Only one number multiplied by 3 to give 6, right?
Mm-hmm.
What is that number?
2.
2. That's right. So y equals 6 divided by 3
Equals to
equal
2.
2. So what were our answers?
2y and 7x.
So our answers were x equal 3 and y equal 2. Those are answers.
Mm-hmm.
X is 3 and y is 2. Because all our simultaneous equations we're working with are the ones with 2 variables. So at the end, you should have your answers for your 2 variables.
Mm-hmm.
All right. Let's go to the next one, Maureen. All right. What would you do on this one, Maureen?
Okay. Let's see. X plus x. Let's see. So let me see. X from x leaves 0.
That's right. This is one where you have something in common for all of them. So you want to just subtract the equations, right? Just like the other one. It's the same kind of problem, right? So just subtract the equations. Okay, subtract. Okay, and then let's just call that 1. And the other one we'll call 2.
So people say x from x leaves 0.
So you subtracting equation 2, subtract number 2 from number 1. All right. Now, so we have it here, Maureen. What's x minus x?
0.
0. That's right. What's 7y minus 3y?
4y.
4y. So that's plus 4y. And what's 64 minus 28?
36.
That's right, 36. Let's see. This will be a plus. So it's 4y equals 36. So we know our answer then. What's the answer? What's y
9.
equal? That's it, 9. Only one number times 4 gives you 36. So y equal 36 divided by 4 equal 9. Now, Maureen, what is x equal to?
X equals 0.
You have to solve for x. You got to take one of these equations, plug in the y value, and solve for x.
Okay.
Not 0.
What we can do?
Take equation 1 or equation 2.
Which one?
Substitute for y, the 9, and then solve for the x. So
We
what would
can
that
do-
give you? Which one do you want to use?
Okay, we could use 2.
Okay, so we'll take number 2. All right, we'll take number 2 and substitute nine for y. So do that. Tell me what you get. What do you get for x?
0.
Get 0. You're putting 9 for the y.
Mhm.
Okay. And this was 3 times 9,
27
27. So x
equals
plus 27 equal 28. Subtract the 27 from both sides, and x would be what?
0.
No, how you getting 0? What's 28 minus 27?
1.
That's it. 28 minus 27 equal 1. Okay, because here you got to subtract 27 from both sides. So what are your answers?
B is y, and 1 is x.
So what is y
9,
and what is x?
1.
Okay, so your answers are x equal 1 and y equal
9.
9. So this would be x equal 1
Mm-hmm.
and y equal 9. Those will be your answers. Okay, Maureen, I want you to do I want you to do C on your own. Okay. Because there again, you have something in common, right?
Yeah. So it's a 2 from 4 is 2. 2 from 4 is 2. Okay, I'm confused.
No. See, you have a plus for y and a minus for y, right?
Oh,
So you can add unlikes and you get a 0, correct? So you can add these equations.
like I say,
Okay,
4. Okay.
add 1, 2, 2. Okay, so this is 1. What's on them? That's equation 1. And this is equation 2. So you're going to add these equations, right? And if you add them, what do you get, Maureen? Let's draw a line under here.
6x.
6x, that's right. Very good. 6x. And a plus 4y and a minus 4y gives you what?
0.
0. Okay. So that's plus 0. And what's 14 plus 4?
And
14 plus 4, not
oh,
subtract.
18.
8. That's right, because you're adding. Remember, I say add them. So now if
Yeah.
6x is equal to 18, we know what x is, right? What's x?
This x is equal to 6x equals 18.
What's x? Only one number times 6 gives 18. What is that number?
3.
3. Okay. So x equal 18 divided by 6 equal 3.
Is 3.
Okay. Now, Maureen, if x is 3, what's y? I want you to calculate y.
Where is y?
Now you can use equation 1 or equation 2, plug in the value for x and solve for y. Tell me what you get.
Okay, I can use the 4x. I can use 2. Right? 2 and 2, 4x minus 4y. right? That's the one I'm using.
Okay, so tell me what you get for y. Okay, you're using this equation. Okay, so I'll put that here.
If I use divide,
Substitute 3 for x. And what do you get for y?
7. No, that's 3 for x.
That means wherever you have an x, you're gonna, this
For
is
the
a
tree.
multiplication, right?
Uh-huh.
So you're
So
gonna
if we get the x,
multiply. See, Maureen, that's a multiplication. So you're gonna
uh,
multiply 4 times 3.
3, it's 12.
That's what we mean by substitute. Okay. So this becomes a 3.
Uh-huh.
Then what do you get?
12.
Okay.
So that'd be 12 minus 4.
12 minus 4y.
Mm-hmm.
That's a 4y, right?
Mm-hmm.
Okay. So this will be 12 minus
Minus
4y is 4.
4.
So what do you do next?
You divide. No, you
No,
add.
no, no. You have a
Start
12 that you need to get with the 4, right? So what would you do?
divide both sides by 4.
Nope. Something you have to do before that. Remember, you're trying to get your constants together. You have a 12 here and a 4 here. So how do I get this 12 on the right side? What do I do to both sides of the equation?
Divide both sides.
12 over 12 is what? I will still have a constant. You do the opposite. If
Add.
12 is being added, what's the opposite of adding? Subtracting. So you've got to subtract 12 from
Both sides.
both sides. Okay, so let's do that. Let's take this equation, subtract the 12 from both sides. Minus 12 on the left side and minus 12 on the right side. Now, plus 12 and minus 12 will give me 0, right?
Yeah.
So what would I have left? Just 4y on the left side. And what's, this is minus 12 over here. So what's 4 minus 12, Maureen?
Minus 8.
That's right, minus 8. This is a minus 4y. Okay, so this is minus 8. So what's my answer? How do I get y?
By dividing.
Yes, dividing both sides by what?
4.
Minus 4.
Oh, yeah.
Divide both sides by minus 4. Okay. And what's the answer?
That's 4 into 4, 1, 4 into 8, 2.
Okay.
4 into 4 is minus 1.
Okay, let me bring that down. Okay.
Right
Okay.
there.
Okay, here we go. So this will be y
Equals
equal minus 8 divided by minus 4. And what's that equal to, Maureen?
-2.
Minus over minus gives what?
A plus.
Plus. So why is this going to be 2? So our answers are what? What was our x? So x equals 3
And
and
y equals 2.
y equals 2. That would be the answers for those equations. All right.
Okay.
Now let's try. Okay. Now, Maureen, we have one that doesn't have anything in common with it, right? So what would you do to this equation?
Which one? This one?
Yeah. 2x plus 4y equals 26
Mhm.
and 3x minus y equals 4.
Mhm.
Now, there's no coefficient variable in common with these two equations, but we can make them have things in common. And how would we do that? Like this is a 4y and this is a minus y. How could I make this a 4y? What would I do
Which
to
one?
both? This one. How can I make this equation where this minus y becomes a minus 4y?
I add in.
That, well, no.
Okay.
You'd have to multiply.
Oh,
Okay, this is 1. We're still doing elimination, right? Elimination method, but we want to eliminate, that means eliminating one of the variables. So we can multiply, and let me just put here, I want you to do that. Multiply.
well, what we call the y? A 1?
Well, it is a 1.
Oh,
When you don't see a coefficient, it's a 1. That's the
Oh.
default. Okay, so multiply equation 1 by 4. All right, so you'll have this equation, multiply that by 4. Then you'll have a 4y. Okay, let's put the 4 here. Now remember, you're multiplying the whole equation, but both the right and the left. You're not changing really the value of it if you do both sides. So what do you get, Maureen, when I multiply this out?
you get multiply 3 by 4 is 12x, right?
Right, that would be 12x.
Minus y
4 times 1 is what?
4.
So what would that be? Minus what?
4.
4 what?
4y.
4y. And what's 4 times 4?
16.
16. Okay. Now I have this equation and then I can add it. Okay. Add to number 1. All right. So let me just take this equation, number 1. And then we're going to add them. Okay. So let's just add these. Okay. What's 12? 12x plus 2x.
14x.
Okay, so that's 14x Okay, plus 4y plus 4y minus 4y.
0
That's right. So that's just plus 0. And what's
equals
26 plus 16?
10.
You're adding, Maureen, not subtracting.
Oh, 10.
No, you're adding 26 plus 16.
Or plus, or add 12, 42.
42. That's right. 42. Okay. Now, if 14x is 42, what is x?
If 14x is 42.
Well, at the math.
So you divide, right?
Yes, but I mean, you divide, but there's only one number times 14 gives 42. And what's that number?
3.
3. That's right. See, at this point, you don't really have to divide. You can say what number multiplies by 14 gives 42. That number is 3. So x equal, to save yourself some steps, do mental math, divided by 14, and that's equal to 3. Now, x is equal to 3, right?
Mm-hmm.
Now, how would we find y, Maureen? We know what x is. How would we find y?
Oh, let's see how we find y.
Substitute x in for either equation 1 or equation 2, and then solve for y. So which equation do you want to use?
1.
Okay. You want to use this one. All righty. Let's take this one. Now substitute 3 for x. So do that and tell me what you get.
So every baby see an x, we put 3, right?
That's it. And that 2x means you're multiplying 2 times x. So you'll be multiplying 2 times what?
3.
That's it. Very good. So you'll be multiplying 2 times 3. So this will be 2 times 3. Now you see you just got one unknown, and that's the y. So what's 2 times 3?
6.
6 plus 4y equal 26. What's your next step, Maureen?
Okay, 6. So you divide both sides?
No.
Okay.
Remember when you have constants
Then you
like this, you got to
multiply,
get them
you
together.
divide.
No. You first got to get your constants together. So you have a 6, 26. You can't start dividing because you still have some constants you've got to get together. So how could you get the 6 over where the 26 is? What operation?
Multiply?
No.
No.
How is 6 connected on the left side? What operation?
That's the x side.
No, the 6.
You divide by both sides, 6 by.
No, 6 plus 4y means you're adding 6. So the opposite of adding is what?
Dividing.
No, the opposite of adding?
Subtract.
Subtracting. So you got to subtract
6 from 4.
6. No, from both sides. So you're trying to get the 6 with the 26, these constants together. So 6 is being added on the left. So you want to subtract both sides. And then you have 6 minus 6 is
Is
0.
0.
And then 26 minus 6 on the left side. So this becomes, let's just copy this.
So it'd be 0 plus 20. 6 plus x equals to 20.
So minus 6. Now you got a
X.
4y there, right?
Uh,
You can't throw away that 4y.
I know.
Okay, so that's minus 6. So on the left side, you'll just have 4y equals
Equals
20. And only one number multiplied by 4 to give you 20. And that number is what?
5.
That's it. So y is 5. We know that because it's only one number that multiplied by 4 to give you 20. And that number is 5. So what are our answers?
Y is 5 and x is 3.
That's right. X equals 3. X equal 3 and y equal 5. All right. Now let's look at the next one. That was what, D? Okay, E. Okay. All right, Maureen. This is one I think you can do yourself because you got two things in common there. So what would you do to this equation?
You subtract 3x from 5x.
Okay.
So that'd be
Would you
2x.
subtract or would you add?
Subtract.
Why would you subtract? Because you got a plus y and a minus y, right?
So we add 5 and 3x is 8x.
Yeah, you'd add because a plus y and a minus y would give you 0.
0, yeah.
Okay, so, okay, this is number 1 and number 2. Okay, so add 1 and 2. Okay, so let's just take these and add them. Okay, let's take out the 1 here. We don't need that. Okay, Maureen, now add these. What do you get? The reason we add them because if we add plus 1 and a minus 2, we get 0, right?
Oh,
So we're eliminating the y. So what's 5x plus 3x?
8x.
Right, 8x. And that's 0. So what's 11 plus 9?
20.
20. Now what's your next step, Maureen?
Let me see. Subtract 8 from both sides? No.
8x means 8 times x. That's multiplication. What's the opposite of multiplication?
Division.
Division. So what would I do?
Divide both sides by 8.
That's right. Divide both sides by 8. Okay. So that means x equal 20 divided by 8. So what's 20 divided by 8?
20 divided by 8 get
As a fraction.
2.5.
Well, you can write it as a decimal. Okay. 20 divided by 8. Okay. So that's equal to 2.5. Now, how would we solve for y?
The subtract.
How would we solve for y? We've got to use one of our equations here.
Oh. Which one we use first? We can use 3x minus 9 equals, we do 2.
Okay, you want to use 2? Okay, so let's take 2.
So we can say, we can say like 2.5 is like 40, right?
Why is it 40?
Huh?
Why is it 40?
I don't know, I just asked.
No, if 2.5 is 2.5, 2.5.
Uh,
Substitute 2.5 for x. All right. Do that, Maureen. Tell me what you get for y.
let's see.
So 3 times x will be
3
3
times
times
x,
2.5.
3 times x, gotta put 3 times x and put 2.5 in.
That's right, 2.5.
5
And what's 3 times
minus
2.5?
3.255.
What's that equal to? Three times 2.5, Maureen. What's that
Or
equal to?
3.
Hmm?
2.5.
Times 3.
7.5.
That's right, 7.5. And that's minus y equal 9. Now what do I do?
You subtract
Subtract what? Subtract is right, but what do I subtract?
7.5 from 9.
7.5 from both sides, right?
Yeah,
7.5
on
from
both
both sides. Remember, to keep equation in balance, you have to do the same to the right as you do on the left. So you get then y equals 9 minus 7.5. What is that, Maureen? What's 9 minus 7.5?
9 minus 7.5.
Yes. That's equal what?
2.9.
No,
You say 7.9
no, 9 minus 7.5.
or 9.
Subtract 7.5 from 9. What do you get?
Minus 1.1.
No. What's 7 from 9?
2.
What's 0.5 from 2?
3.
No, it can't be more. It's got to be less. You're subtracting.
Or subtract 7.9.
No, 9 minus 7.5.
Oh, the other way around.
Yes, 9 minus 7.5. Now, 9 minus 7 is 2. Now, what's 0.5 from 2? What's that equal to?
1.5.
1. What is it?
I subtract 9 from 7.5.
You mean
I
you
get
subtract,
1.5.
yeah, you mean you subtract 7.5 from 9. You
Yeah.
get 1.5. So what are your answers?
Okay.
X was equal to what? X equal 2.5
5
and y
equal
equal
to
1.5.
1.5.
Okay.
Mhm.
Now, how could we
Okay.
check that, Maureen? How could we check that?
To get what?
How could we check that this answer is right?
I don't know. 2.5 and what is that? I don't know, Miss Barron.
We'd have to substitute the x and the y value and see if we get what we have on the left. What's 5 times, well, 3 times 2.5 is 7.5 minus 1.5, and that does not give you 9. Now, if you take these values and substitute them into this equation, and you don't get the number, then there's something wrong. If you take the x
So
and put
if you
it
multiply
here
3 by
and the
2.5, you get 7.5.
and then minus 1.5 is not 9, it's 6, right? So 5 and 3 is 8 plus is 0, 9 and 11 is 20.
Let's see.
20 divided by 8, let's see. That's 2.5, 3.5, 7.5. So 9 minus 7.5 is 1.5. So what is wrong? Because these numbers don't come out right.
Mm-mm.
5x plus y. Let's see if this is 3. Let's see. 10 plus 1. 6 minus 1. No, it's not coming out. It's not coming out right. If I substitute these x and y values, I don't get back what I have here. In other words, whatever I put in for x and whatever I put in for y, I should get this 11.
Oh,
Unless there's something wrong with this equation. You know, it could be the equation is wrong. Let me see if I have it here, if it's copied incorrectly, because that's why it's good to check. Let me just see here. It could be the equations are incorrect.
oh.
That's normally what happens when you don't get back the right answer. Let's see. Let's see if we had a well, E may not be correct. Let's see. I'm trying to find the equation where I copied it, because maybe it's not copied right. Let's see, that's 5x plus y, 3x minus y is 9. X is y is 2.5. X is 2.5. Y is I have y is Oh, you know what the problem is? Y is a negative, Maureen.
Um,
That's why it's not coming out right. See, Y, okay. See, this is a minus Y.
um,
This should be a minus Y. Okay. Okay, so if a minus Y is 1.5, then a Y is going to be a minus 1.5, a minus 1.5. So this should be a minus. Okay. And if we put the minus in, see 5 times 2.5 is 7.5, minus, let's see, 7.5 minus 1.5. Let's see. Yeah, 5 times 2.5 is 11.5 minus 1.5. I'm sorry, 12. That would be 12, and then minus 1.5 would give you 11. So if this is a negative, which it should be, because see, that's a minus Y. So a minus Y is 9 minus 7.5, which is a 1.5. Therefore, a plus Y, multiply both sides by minus 1, would be equal to a minus 1.5. Then if you substitute that here, let's see, 3 times 2.5 is what? 7.5 minus a minus 1.5 will be 7.5 plus a 1.5 will give you 9. Then it comes out right. Except this should be negative. And we see here, this was a negative Y. So a negative Y equal 1.5 would be a plus Y equal 1.5. There we go. That's why it's good to check. See, once we check with what we have, it didn't come out right, but we had misplaced our sign here. This should be a negative Y. Okay. All right, Maureen, let's see. I think we have one more, Maureen. And let's see if you can solve that one. Now you've got something in common there.
yeah. 4Y and 4Y.
That's right. So you can subtract them.
So that is,
So do a subtraction and tell me
that
what
is-
you get.
the first one is be 3x, right? And
That's right.
subtracting
That's right.
1 yeah. So we
You're
get 3x.
absolutely right, Maureen. You did it. You got a 3x. So you got it started. Now finish. Okay.
3x
Okay.
minus 0 minus y.
Well, when you say minus minus, that's a plus. So you're right. That's going to come out 0.
So you write
Here we
3.
go. Okay. So when you did the subtract, what did you get?
3x
Okay. Okay. So let me draw my line here. And you're right. You get 3x. Okay. And a minus minus plus. So that's going to give you 0. Correct? Okay. So that's 3x. And that's going to be 0 minus a minus. This minus becomes a plus. So now 24. So this right here, you subtract. So
then we subtract 3 from 24.
That's right. 2 from 1. So this would be equal to, what's 24 minus 3?
21.
21. That's right. Okay. So you know your answer then. Only one number times 3 give 21. What's that, Maureen? 7. That's right. So x
Close to 7.
x equal
The 7.
Yes, 21 divided by 3 equals 7.
Equals
Now, what is y, Maureen?
so
Take
y
any equation. Take the simplest one, this one. Plug in the 7 and solve for y. Tell me what you get.
3.
Okay.
I put 7. I put x equals 4.
Substitute,
And we subtract, right?
substitute 7 for
Right.
x. So
So it'd be 7 x.
no, x is right here. So you put a 7, right?
Right.
So for the x, you put the 7. So
7
7
minus
minus
4y
4y equal
equals
3.
3.
Now, what do you do next, Maureen?
The subtract
That's right. Subtract what?
both sides by 7.
Subtract 7 from both sides. And that would give you what? A minus
0.
4y. Well, 7 minus 7 is 0. So
So yeah,
minus 4y
y
equals
equals
3
3.
minus 7. Okay. Let me just put what we did
So
here.
that'd be
Okay, so we subtract 7 from both sides, minus 7. And like you said, 0, and then minus 7 here.
will that be
Okay, so that's 7 minus 7 is 0. So we get
0
4y. So
y
what's 3 minus 7, Maureen?
4y 4
Plus or minus?
a plus
3 minus 7?
is 4 minus 4.
Minus 4. Plus minus is going to give you a minus because you have more minus than plus, right? So that would be a minus 4.
4.
So what's y equal to?
4.
No. You have minus 4y
Y
equal minus 4. So what is y equal to?
0.
No,
1
1. That's right, because y will be
is
equal to
equals to
minus 4
4
divided by minus
4
4, which will be equal to
1.
1. That's right.
Yeah.
So x is equal to 7 and y is equal to 1. So x equal 7 and y equal 1. That would be the answer. Now, Maureen, do you understand independent and dependent variables? Do
We
you
do
know
them
how?
already, but we do them already, but I really can't remember. But no
Okay,
problem.
because I think the homework you have for, well, Thursday's no class, but I gave you, I think 5 problems to do, and one of them had independent.
But I didn't see that. You know what we see today is the ones that we do for homework.
Yeah, but you didn't see the one I gave you with the 5 questions?
No, I see one.
I emailed them the same time.
But you see ones that we do the first, with like the woman at work with the basic and the store thing, and the buses. I see that one.
But when I emailed it, I had 3 files. One was the one for not for Thursday, but before the following Thursday.
No, I didn't see that. I only see Walmart was for, and was that you saying Thursday? Was the The trader that gained this day, that's all I see.
Yeah, but there were three separate files. You didn't see the three?
No, mm-mm.
Well, I'll
I
send it
check and I
again.
didn't get it.
I sent it again because I emailed it to everybody.
I didn't
I'll,
get it.
I'll email it again.
Okay.
Well, now just to go through independent dependent variables, uh, usually when we have like y equal mx plus b, the y is dependent on the x, right?
Uh-huh.
Now, let's just look at some examples here. Now, the more time people spend using social media, the less they read books. Now, which of these variables would you say is dependent and which one is independent?
But the more time people, you mean this, so the more time people spend using social media
Yes, the less
and
they
less
read
time,
books. So which of these variables is independent and which is dependent?
I will say the people spending time is dependent
People spending time what?
on social media. And I would
Okay.
do the less reading is the independent.
Is you saying which one you saying dependent?
The less reading.
The less they read books is dependent upon the time they spend using social media. That's correct.
Mhm,
Yeah,
mhm.
because if they spend more time on social media, they're going to spend less time on books. So reading the books is dependent upon the time they spend using social media. Very good. Now, let's take this one. Drinking energy drinks makes people more aggressive. Which one is dependent? Which one is independent?
I would say, and the drinks is like independent.
Okay.
Uh,
And what is it dependent?
I think the more the people get more progressive.
Right, people more aggressive is dependent upon drinking the energy drinks. Very good. You got a good handle on it, Maureen. Taking a nap in the afternoon makes people more focused for the rest of the day. Which one is dependent? Which one is independent?
I would say the taking the snap is more dependent than focus. Okay. Taking a nap in the afternoon make people more focused on the rest of the day. I would say that is independent.
What is independent?
Taking a nap.
Right, that's independent. The focusing is dependent upon
Dependent.
them taking a nap. Very good, Maureen. 3 out of 3. Okay. What about this one?
And then time with the family that will decrease the amount of stress someone is feeling. So spending more time on the family that will decrease. This is more independent.
Right? And what's the dependent?
The stress.
The stress is dependent upon spending time with the dog. Okay. 4 out of 4. What about the next one?
Eating breakfast in the morning increases the ability to learn in school. Eating breakfast in the morning is dependable
Okay. And what's the dependent?
in increasing the ability to learn in school.
Right. The increasing ability to learn in school is dependent upon eating breakfast in the morning. All right. 5 out of 5. Now, these are a little more challenging. What do you think about number 1?
Students watch a cartoon either alone or with others, and then realize how funny they found the cartoon to be. So I would say, okay, students watching a cartoon either alone or with, and it's rated how funny they found. I would say the cartoon was independable and the students watching was dependent. No.
What would you say?
I would say the students watching the cartoon either alone or with others is like independent.
All right. And what's
And the
dependent?
rated and the rated is the independent.
Okay, the rating is dependent upon them watching the cartoon. Now, this one, it could be either alone. You'd really have to test it out. It could be either alone or with others, because one of these may not really affect that. All right. But the rating of how fun it is dependent upon them watching the cartoon.
Oh,
All right. Now, what about the last one?
okay. Some elementary school teachers were told that a child's parents were college graduates, and other teachers were told that the child's parents had not finished high school. They're both rated each other. Okay. I would say the elementary school teachers told the child's parents that they were college graduates was dependent. And the other parent with the grades was independent.
So, what's the dependent variable?
The some elementary school teachers were told that the children's parents were college grads.
No, the dependent variable is the rating of the child's grades. It's dependent upon the education of the child's parents. So the education of the child's parent is the independent variable. The dependent variable is the rating of the child's grades. All right. Very
Okay.
good, Maureen. You got an excellent handle on independent and dependent variables. All right. So you have your homework. So I don't really have to send you anymore. But I'll send that again since you said you
Yes,
didn't get
send
it.
it to me again because I didn't get it.
Yeah, I'll send it again. I'll just send it out
And,
again. But I
and
sent,
you gonna say we do just now? Not this
sorry.
one where you know the ones that we do just now before the independent one.
Oh yeah, yeah,
That,
yeah. I'll be
yeah,
emailing
yeah,
that to
yeah,
you. Yeah,
yeah,
I'll be
yeah.
putting it on YouTube and then I'll
Okay.
email it to you.
Yeah, and the brand new one working.
And then the homework that's due before, not by this Thursday, but before
I
the
know called
next
Thursday.
Thursday.
Yeah, I
Yeah,
know. Yeah,
Thursday is a holiday, but the homework I sent you is with the 5 questions. That's the one that's due
yeah.
before a week from Thursday.
I didn't get that.
Okay, I'll send it again.
Uh-huh.
All right, Maureen, thanks for joining.
And thanks, and have a good holiday.
You
And talk to you.
too.
Yeah.
Enjoy
Okay.
yours. All right.
All right. Okay. Bye bye.
Bye bye.